So as we march into hyperbolic geometry, this is the first result that's really weird. Similarity implies congruence. So what does that mean? Similarity implies that the three angles of one triangle are congruent to the three angles of the other triangle. So if this scenario happens, then the triangles themselves are congruent. So this will drive home for us that the idea of similarity in the Euclidean plane, same shape, different size, does not exist in the hyperbolic plane. Does not exist. So here's what we're going to do. This is triangle ABC. This is triangle DEF. And we will suppose that triangle ABC is similar to triangle DEF, which means that angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. That's the idea. So here's what we do. We bring this triangle into this picture. We suppose, for the sake of contradiction, that the two triangles are not congruent. If the two triangles are not congruent, then AB is not the same size as DE. We get to assume that one is bigger without loss of generality. We will assume that AB is the longer segment without loss of generality. Similarly, we'll assume that AC is longer than DF. So there is some point on AB such that AB prime is congruent to DE. And there is some point, we'll call it C prime, on segment AC such that AC prime is congruent to DF. And what that gives us is that triangle A, B prime, C prime is congruent to triangle DEF. So now we can just focus over here and say, well, what the heck happens over here? What goes wrong? Why can't this happen? Well, angle B prime is congruent to angle E, and angle C prime is congruent to angle F. And yes, there are two angle B primes. This is triangle A. This is angle A, B prime, C prime, and this over here is angle C, A, C prime, B prime. So this setup is the same as this setup. Well, what does that mean about this shape here? Well, this angle measure, this angle here is the supplement of that angle there. And this angle here is the supplement of that angle there. And so this quadrilateral down here has an angle sum of 360. And that is a contradiction. In hyperbolic geometry, we do not allow quadrilaterals to have an angle sum of 360. So this can't happen. What made this go wrong? Well, what made this go wrong is when we assumed that B prime was on the segment rather than at the endpoint. So it must be that AB is congruent to DE, and if that's the case, then the triangles are congruent by angle side angle. So in hyperbolic geometry, if the three angles of one triangle are congruent to the three angles of the other triangle, the triangles are not just similar, they are congruent.